So let's go ahead and create one of our custom Python nodes. From object level, let's jump into Python node and drop down on null. What we can do here is edit the parameter interface to create some custom parameters that we need for this. Let's go ahead and add a string and a separator, and I need a button as well, which is right there. There's some other stuff here, copy and cache input. Let's make those invisible, and let's put the string before the separator. So let's call this one code, label it code, and we're going to leave the type as a string, but we're going to set it to multi-line string. This literally creates a string parameter of multiple lines, which looks like a window in which you can type your code. Now let's set the language to Python. This basically makes the string parameter into a Python interpreter. Now let's select the button, and in name, let's type run_code. And for the button's label, type run code again. We will set the callback script to be a Python script, and we're going to make sure that when we click the button, it's going to execute the code that we've written. Let's type in exec, that means execute, and then we can write who.node, and as we've seen before, to reference the current node, we just type a dot in there, and we're going to go parm code, which is what we've called the parameter in which we will be typing our code, dot eval. We've seen that one before. It evaluates the parameter. So what this does, it's going to look at the current node, at the parameter called code, and evaluate it. And then exec will execute it for us. Now, if we look at our null node, we should have our code window here. And if it all works, we can go print anything, run the code, and there we go. It prints it right there. So now we have our manual Python node. This effectively allows you to store scripts on a node and run them from there, or run them from anywhere else really, by calling the correct script and executing it. I have used this technique many times, and it's especially useful when you're building procedural tools in which you want the user to be able to execute scripts on demand. Now let's have a look at modules, because we haven't actually talked about it that much yet. Modules are basically files containing Python definitions and statements. For example, the math module, which comes with your install of Python by default, contains a plethora of functions that do maths, and all we have to do is call the function and pass it the values we want to be computed. This means we don't have to write the whole function ourselves, because that hard work has already been done for us. The math module is just one example. There are many modules available to us, and if it isn't pre-installed with Python, we could find what we need online, download and install it module on top of what we already have. That is, given the module we need is really available. But that means that the code has been written for us, and that basically the hard work has already been done for us. All we have to do is use the modules. The Python library of modules is extensive, as users worldwide write modules for it. Most, if not all of what you need though, comes pre-installed. In some cases, a module needs to be imported before you can use its functions. Let's have a look at doing this. There are some examples I wanted to show you. I'm just going to copy some code in here, a math function, a power function, and if we want to use the math module, we have to import it first. To do this, we can type import math at the top of our code, and this makes the functions in the math module available to us. B is math.pow, 2 to the power of 2. We would expect this to evaluate to 4. To output that, let's write print b underneath. Now if we hit run code, we get 4.0 in our console. If we would remove import math and run the code again, you can see that we get an error saying math is not defined. That is because we are no longer importing it. An improvement in Houdini nowadays is that it has its own math functions, meaning we don't really require the math module. We could just type b is pow, and then in between the brackets type 2, 2, without calling the math module, in which case Houdini will print out 4. The main difference here is that Houdini natively returns an integer value of 4, while the math module returns a float value of 4. Let's have a look at the time module as another example instead. I'm going to paste in another line of code, time.strf time, and then inside there you can see %a, %h dot %m dot %s. strf time is a function as defined in the time module. What we pass into the function, %a, %h, %m, %s, makes no sense at face value. However, inside the time module, these have been defined to mean something. Someone has spent time, no pun intended, setting out a number of rules and definitions giving these symbols meaning. All we have to do is import the time module and pass them into a function from the time module. This module understands %a to be the current day, %h to be the current hour, %m to be the current minute, and %s to be the current seconds. If we would type a is time.strftime, then print a, and run that code, we will get an error stating time is not defined. We need to import time first. So let's add import time at the top of our code and run it again. Now it prints out Sunday 22/26/15. Obviously, the output of this function for you should be something different. This is an example of requiring to import a module in which things have been defined for us, and if we want to use those definitions, we need to import that module. This concludes this video, and in the next one, I will be wrapping up this first module.